What's up, everyone? What's up, guys? It's been a long time. So today we have one more thing to prepare for. That is my semester exams are going on, and I have to study. Yep. Tomorrow is data structures. Gotta gotta read. I'm not gonna read. You guys know me. So what I am gonna do is just suck it up and read. Sometimes when life gives you lemons, you make lemon juice. My life gave me an exam. Gotta write it. Otherwise, get out of the house. Hey, boy. Everything is, I know. Pretty much, I listen in class, so it's not gonna be too much of an issue. Only problem is you guys are not gonna be able to see what I am reading. So if I can find a much better camera angle, I'll put that and I'll do that. Let's check. Let me check. Let me just check. Yeah, boy. Uh, Come on, what's wrong? Mm, uh, what is this? OnlyFans? Ah, ah, cannot. Well, this is a little bit hard. Let me see. Let me see what I can do. ほっほっほ。お前はもう死んでいる。あなたは日本人ですか？はい。私の名前はアビラムです。私はハンサム、かっこいい男です。Heck yeah. Now I am gonna put my laptop in that place and you guys are gonna be able to see me study. Heck yeah. Oh, heck yes. Let us start the studying. I'm gonna stop that. Intricate stuff. Right? If I can get that. All right. Now I'm gonna study. Pretty much. I am gonna study and I should put a timer because I said this is gonna be a pomodoro session, boys. Boys and girls. That is stupid. I'm gonna stop doing that. Let me put a timer. Timer. Timero. El timero. Timero. 20 minutes, 30 seconds. Before I actually start, I'm gonna explain what we are gonna do. I have 5 units to prepare. So it's 5 things that I should look at. But from an exam perspective, I should be looking at things that I don't know. Because many times in my semester exams, they have given repeated questions. Why should I waste my time on things that I already know when I can focus on things that I don't know? So I'm going to do just that. Thing is, I don't know what I don't know. I got some question papers dangling around here somewhere. I don't want to write the exam, honestly. Nah, I'm just joking. So this is the exam little brother. It's a little bro of the big bro. I did pretty good. So in data structures, we have some programs. I just want to pass this exam, bro, to be honest. Mm, uh, as you can see, my well written. Can't you guys see it? No. No, you can't see it. All right. Define sorting. List out any two applications. I don't know, but I did write it. All right. Okay, let's read what I don't know. All right. Justify with an example. When does bubble sort is better than selection sort? Give an algorithm for both sorting techniques. Design a code snippet. Yada 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 yada. Blah 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 blah. This is interesting, not boring. That, but it might be boring to you guys. So let me see. Outline. Okay, I got it. I'll wing it. You know, when it comes to programming in C, I'm good with concept. I'm good with, solving problems, looking at it in different ways and stuff. The only thing I suck at is actually writing the code for the program. I suck at it. I really do. So I'm going to focus on that, but also focus on passing my exam. I don't know if you guys can see, but let me just, change some stuff. Mm. Display capture. So whatever is the what? Wait a second. What? Okay, then let's put the display capture. Well, now you guys can probably see some stuff. So let me just do this one thing. Oh, I just forgot what I was gonna search for. Wait a second. What was I? What? Ah, yeah. I was about to check my WhatsApp. My WhatsApp. My WhatsApp. All right. There are question papers. What do you got? Short answer is this much. Define sorting. This sort an interpretation. When the other sort. Hmm. Can you guys even see what I'm seeing? Is this even visible? Now it should be a little bit more visible. Okay. Okay, I'll stick with this. The sad part is that my exam is tomorrow. I don't have time to study anything entirely new. So I have to make do with it. All right. What would we call? Ah, yeah. Simplify the entire PDF. Okay.
Your AI companion.
Allow.
It's great to chat with you
Simplify the
anytime.
entire
You
PDF.
can ask me anything, bounce ideas around, or just have a friendly conversation.
Did
I'm
you
here
hear
to
me?
make your day a bit brighter. So, what's on your mind this
Oi.
afternoon? Hey, what's up? Hey there, what's new?
Simplify the entire PDF.
Sorry, I can't process or simplify PDF documents directly. Maybe I can help summarize key points if you share the
Should I do
content
this
with me.
manually? Oh no.
What's up?
Bad. Hmm. So first unit is searching algorithms, and this I'm going to be staring at the screen for a long time, so might as well put the glasses on. Searching algorithms. Wait a second. I just came to look how I look. Wait a second. Searching algorithms. Sorting techniques. Data structure basics. Linked lists. C programming implementation. So this whole thing is just about programs. All right, where's the concept then? Hmm, Let me see the whole question paper. This is gonna be a pain in the butt. I'm sorry. Explain the implementation stack using array representation. I'm beginning to doubt whether I'll pass this exam. There we go. Hashing. And looking at this makes me want to sleep. Hmm. I want to sleep. I don't want to study, bro. The moment I look at the book, damn. Well, I understand that I know the concept. I can write something in the exam. I don't know programs, the concept of the programs. If I know them, then everything will be a cakewalk essentially. Just gotta know them first. I just want to have a 20-minute nap, so you guys. Alright, I won't bore you anymore. Alright, let's actually start. First of all, I'm just gonna revise. That takes the least amount of work, and I like it too. Have a pen. I'll just go and get my pen. So, so there are some things that I don't know. Is the chat now? Is the stream still streaming? That is good to know. What I don't know are searching all programs. Searching, sorting, stacks, linked lists, queues. I gotta study all of these. Another thing is binary search tree. I don't know how to binary construct a binary search tree. We gotta see that. Double hashing. I don't know how double hashing works. I have to see that. Graphs. Graphs, not so much. Not much to be learned in graphs, but just the types of graphs. I got the adjacency list and adjacency matrix down, so there's nothing more he can ask from that unit or that lesson. My only problem is programs. There are a heck ton of programs, and I gotta study those. Well, Better get moving. What if I turn this way? Hmm? This way is much more nice. Okay, this way it is. Just gonna. What's the easiest thing to learn among these things? Double hashing, graphs, programs, BST, clarification. I'm gonna go with the BST because it's just a little clarification. So, mm, there we go. Hmm. Okay, let's do this. I got the correct answer. Yay! Next question. One more, some on BST, and then I'll move on. Second one finished. Yay. Bruh, what? When did it even finish? I didn't even hear it. Alright. Nice. Driver is not sounding. Got it. Now the plan is I wanted to play a little game as a reward, but I need to sleep, man. I need to have a nap. So after one 20-minute nap, I will be sleeping right here. Oh, yes. Mhm. Mm, this one just 5 minutes, and then I'll get back to it. Now, the day went like this 12 hours study, one is going up. I slept for like 40 minutes. Sheesh.
Super hexagon. Begin. Game over. Begin. Game over. Begin. Line. Game over. Begin. 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 Game over. Again. 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 Game over.
I hesitated. And then my turn.
Begin. Game over. Begin. Game over. Begin. Game over. Again. Game over. Again. Game over. Again. Game over. Begin. Game over. Again. Game over. Again. Game over. Begin. Game over. Again. 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 Game over.
Next time, I'm gonna hit 10 seconds on the cloud. I mean it. That woke me up. That's the reason I played that game, because it would wake me up. And it did pretty much its job. Dude, this sucks. Mosquitoes bit the heck. Why do even mosquitoes exist? What's the purpose of your insect kind? You suck anyway. Oh, man. Better remove this. Wait, so 30 is deleted, 30 is child node, 20 is good. So here 50 is gonna be deleted, so 30 should be put here. 30, 80, we're going good. Why did you put 60? This doesn't make any sense. If you want to apply case 2, apply that to the direct children. Why go even below that? Alright. If there is just like this little one, take this one. Got it. But if it's like this, you don't take the next, you need the next one. You attach this to this to this. Let me write that one down for me. So if we delete in 30, the graph should probably look like this. 30 below. 10, 25, 80. So if we delete in 50 itself, then the graph will look like this. That's the root node. So we gotta go deep inside, penetrate inside the tree. And there we get it. Yay! So if it's the root node being removed, you got two nodes. Normal node, you got normal node. Huh. Alright. I guess that is it. So I can successfully scratch one thing off. BST done. Done. Now, programs, it's too much. I'm not gonna do it. My rule is to do the thing that takes the less time first. So naturally inclined to double hashing. Graphs are all for there, but anyway. Mm, alright. Thought I was forgetting something. Hey, hey, boy. No, no, not search operations. We gonna go to hashing. Hmm. 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 Oh yeah, this one. Hmm. Got it. So double hashing is used to reduce secondary clusters. Is that what it's? Yeah. To reduce secondary clustering, double hashing is used. Double hashing is where you take two hash functions instead of just one. Whenever any collision occurs, you can use the second hash function to reduce secondary clusters and also input all the values, the hash values obtained from the hash function itself. Great! Let's do it! See, the thing I don't get it is he said 27. Here it is mentioned 27, but he put 22. He didn't do this mistake for the remainder of the sum, so I'm just gonna pretend that is what my SAR did. So Hmm. So how do I do the mod? What the heck? Huh? How to get reminder value? How to get mod in Casio FX 991 ES Plus? Divide. Wait, what? Let me try this. So I got 692 divided by 7. I got 98. 7 times 98. 686. 692 minus 686. Bro, this trick works. Pretty good. I am ashamed that I don't know this, but pretty good. Um, yeah. 692 divided by 5. 138. 138 into 5. Alright. I just go to the calculator instead of using my brain. Because if I use my brain in the exam, I'll probably fail. And if I probably fail, I'll probably panic. Why do all that? Hmm, finished. Alright, excellent. That is pretty quick. Alright, it's gaming time. I'm gonna increase the study time to 25 just so I can do problems because right now I'm not finishing my problems. Should I play Super Hexagon or something else? I'll play Super Hexagon.
Super hexagon. Super hexagon. Begin. Line. Game over.
That's on the time. Yeah, the time.
Begin. Line. Game over. Begin. Game over. Begin. Game over. Begin. Game over.
Dude,
Begin. Game over. Begin.
I don't suck this much.
Line. Triangle. Game over. Begin. Game over. Begin. Line. Triangle. Square. Game over.
Well, I was reaching, just reaching best. That's
Begin. Line. Triangle. Game over.
enough. This is actually this level, but I finished it, so this is harder.
Begin. Game over. Begin. Game over. Begin. Line. Game over. Begin. Game over.
I'm
Begin.
just gonna show you the original level, how it looks like. Super peaceful. The easiest.
Line. Triangle. Square. Game over.
That's pretty boring, so
Begin. Line. Game over. Begin. Game over. Begin. Game over. Begin. Line. Game over.
missed it.
Begin. Line. Game over. Begin. Game over.
When many mini lines come, I don't know what to do with
Again.
this.
Game over.
This is my favorite level among this game.
Begin. Game over. Begin. Game over.
Yes, that's all the time. So the Bluetooth still connected? No, they're not. 25 minutes this time. Steam is still streaming. Pretty good. Hmm. What? Okay. Um, now that I got a collision at uh, third place. Yeah, no, fifth. Because I got the key as 45. 45% of 5 is 5. Obviously, 15 is still there. So I did the second double hashing method. 7 minus. So the largest prime number minus key percentile, the largest prime number. So 7 minus 45% of 7, that is 7 minus 3, 4. But 4 is also occupied. So the next step is to reduce both the prime number and the key. So the new key becomes 4, and the new prime number becomes the prime number less than the original one. So what's the prime number less than 7? It's 5. 5 minus 4% of 5. So then that is 4% of 5 is 0, right? So that's 5 again. It's getting an error again. I have to keep doing this? No, this is different what it's doing. Hey, wait a second. That is something else. That is a new formula. So he didn't apply a double hash function. He did entirely something entirely new. What is this? Okay, so oh, okay. So P is the collision of hash function 1. P dash is the collision of hash function 2. Got it. Now it makes sense. So we just gotta increase the zero value until we get something. P, what's P? The P is 5 plus 0 star. Anything star 0 is 5, so 5 plus 1 star 4 is 9. 9 is also occupied. 5 plus 2 star 4. 5 plus 2 star 4 is pretty big value. 8 plus 5, 13. I'm getting 13, right? Oh, we got a percentile with 5? Okay, with 10. Okay, I forgot the percentile max size 10, 10. Okay. P plus n star p dash whole percentile max size. Got it. That is 3. 3 is unoccupied. Let's put this bad boy at 3, 45, and 47. So 47% down 10. So done. That sum is done. Advantages of open addressing. What is open addressing? Open addressing provides better cache performance. Cache. How am I supposed to pronounce this? as everything is stored in the same table, no links in open addressing. Problems of open addressing techniques. What is open addressing? Open addressing is closed having, right? If I remember, open addressing is supposed to be, yeah, closed hashing. Closed hashing that redistributes the collision values inside of the hash table. Chaining open hashing, it just attaches node and continues on. So it is. Let's see. Advantages. Open addressing provides better cache performance as everything is stored in the same table. No links in open addressing. Problems of open addressing techniques. Open addressing requires more computation. An open addressing table may become full. It requires execute to avoid clustering and load factor. What's the load factor? Performance of open addressing m equal to number of slots in the hash table, n equal to number of keys to be inserted in the hash table, load factor is equal to alpha equal to n percentile n. So number of keys divided by number of slots in hash table. Expected time to search slash insert slash delete less than 1 by 1 minus alpha. So search, insert, and delete take 1 by 1 minus alpha times. Let me write that down. M equal to number of keys, n equal to number of slots. What is this value? Load factor. Load factor equal alpha equals to n percentile n or n percentile m, right? N percentile m less than 1. Search, insert, delete. It takes less time than 1 by 1 minus alpha. It's saying, oh, it takes that much time. Got it. Takes expected everything. Open addressing is Open addressing has much more better cache because everything is inside of the table. There is no links in open addressing. Disadvantages is that sometimes the hashing table may be full. It requires more computation and load factor is also it requires extra care to avoid clusters and load factor. Yeah, got it. So I can tick off double hashing too. The programs are the things I hate, man. I hate them. Why? Because I don't know how to rewrite them on my own. I hate to buy hard programs. I would love to write them down, but graphs. Let's go to graphs. Give me your money! If some thief comes like this, you gotta go. You gotta take the gun and take the gun and take the bullets off the magazine. It comes like this. You go to punch the thief, and the thief will go. I never encountered a thief, but if someone puts a gun at your face, you go, and they'll go away. Audio, yo, this, I'll message you. What's the time? Oh no, I'll message later. In fact, I shouldn't make him wait. Wait a second. Back, back to the table, baby. Graphs. What is a graph? A graph is defined as a set of G equals to V, comma E, where V is a non-empty set of vertices or nodes and E is a set of edges. Each edge has either one or two vertices associated with it, called its endpoints. An edge is said to connect its endpoints. Okay, so in graphs there are vertices and edges. If an edge connects two vertices, then the vertices of that edge is said to be its endpoints. So technically, graph G equals to V comma E. That is for normal graphs. But if it's an infinite graph, then V 1, 2, 3, 4 infinity, E 1, 2, 3, 4 infinity. The set of vertices V of a graph G may be infinite. A graph with an infinite vertex or a set or infinite number of edges is called an infinite graph. A graph with a finite vertex and a finite edge set is called a finite graph. Graph terminology. Vertices. A vertex, often referred to as node, is a fundamental unit of a graph. It represents an entity within the graph. Every node/vertex can be labeled or unlabeled. An edge is a connection between two vertices in a graph. It can be either directed or undirected. In a directed graph, edges have a specific direction, indicating a one-way connection between vertices. In contrast, undirected graphs have edges that do not have a direction and represent bidirectional connections. So vertex, often referred to as node, is a fundamental unit of a graph. Damn it. Yeah, it's a fundamental unit of a graph. It can be labeled with something, it can be labeled or unlabeled, and that's all it is. There's nothing to be told on. What is a vertex? A vertex is a fundamental unit of a graph, which is also maybe referred to as a node. It can be labeled, it could be unlabeled. An edge, on the other hand, is something which connects vertices inside of a graph. An edge can be weighted, directed, or undirected. If an edge is weighted, then that edge is now having a weighted value. If an edge is directed, then that edge is now having a direction, either from one vertex to another or vice versa. Or if the edge is undirected, it is bidirectional. Next, adjacent vertices. Two vertices are called adjacent if there is an edge between them. In the following graph, G are adjacent vertices. Got it. Got it. Adjacency, got it. Order of a graph, number of vertices. Size of graph, number of edges. What? You can write that down. C is adjacent. Size of a graph is 3. Order of a graph is 3. Order is the number of vertices. Size is the number of edges. 4. Got it. Degree of a vertex. The degree of a vertex in a graph is the number of edges incident to that graph. In a directed graph, the degree is further categorized into in and out. Okay. The degree is the number of edges that is incident on a graph. If it's an undirected one, it is simply an edge being connected between vertex. If it's an directed graph, it is further categorized into in degree and out degree. A walk. Hmm. A walk is a sequence of vertices and edges of a graph. If we traverse a graph and then we get a walk. Edge and vertices both can be repeated. Walk can be or open or close. Walk can be repeated anything. Okay. A walk in which no edge is repeated, then we get a trail. Vertex can be repeated, edge is not repeated. It is a trail in which path. It's a trail in which neither vertices nor edges are repeated. If we traverse a graph such that we do not repeat a vertex and not repeat an edge, it's a path. Traversing a graph such that we do not repeat a vertex nor we repeat an edge, but starting and ending vertex must be same. We can repeat starting and ending vertex, but then and only then we get a cycle. So a path is same as a cycle, but in a cycle, the starting and ending points are same, but the path is not so. What's a circuit then? A circuit is a trail. Alright, if it's closed, it's supposed to be a circuit or a trail. It's a circle or it's a circuit or a cycle. Well, if it's a cycle, if it's a cycle, then it's something of the path which is having the same ending and starting points. But if it's a trail, it's not so much. The only thing I've mentioned about ending and starting point is just cycle. I'm just not gonna think about it that much. A tree. A tree is a connected, undirected graph with no simple circuits or a cycle. So a tree is an undirected acyclic graph. Okay. A tree cannot contain multiple edges or loops. Therefore, any tree must be a simple graph. This is a tree, and this is also a tree. So a tree is something like a simple acyclic graph. A tree is a connected undirected graph which doesn't have any cycles or circuits. That's all it is. A tree cannot contain multiple edges or loops. Spanning tree is just methods of that. Spanning tree is a subset of graph G, such that all vertices connected using minimum possible number of edges. Spanning trees is a subset of graph such that all vertices of that graph must be connected with the least amount of edges possible. So all vertices are there, but with less edges. Efficiency is more percent. For that, there is a formula. K equal to n percent of what? N, n power n minus 2. Let's say n is 4. Then 4 power 4 minus 2. That is 16. For number of spanning trees, n power n minus 2. Minimum spanning tree. Minimum spanning tree is defined as a spanning tree that has the minimum weight among all possible spanning trees. But then, formal terms, a directed graph is an ordered pair. V is a set whose elements are called vertices, nodes, or points. I'm sorry, what? V is a set whose elements are called vertices, nodes, or points. I'm reading directed graph, digraph. Okay. G equals to VE, where V is a set of whose elements are called vertices, nodes, or points. E is a set of ordered pairs of vertices called directed edges that have after directed lines. Got it. Indirect. Is it Brahman, node, point? Here also versus nodes, or points. Unordered pairs of vertices. What is this? Ordered pairs of vertices. Directed graph has ordered pairs of vertices, no directed edges. The undirected has unordered pair of vertices called undirected edges. Let's go and Spider-Man, Spider-Man, here comes the. I'm gonna stop. It's time for some little game. Dude, I look bad anyways. Let's just continue. Should we play Alto's Adventure? Alright, well, it's more time to lower, I see. I would say, oh no.
Super hexagon. Begin. Game over. Begin. Line. Excellent. Game over.
1 second more. It's pretty good. Let's have this.
Begin. Line. Game over. Begin. Game over. Begin. Line. Game over. Begin. 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 Line. Triangle. Game over. Begin. 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 Line. Game over. Begin. Game over. Begin. Game over.
Should have started with all right, let's go back to it. A regular graph is a graph in which every vertex has the same degree. There are more these. A regular graph is a graph in which every vertex has the same degree. The complete graph on n versus denoted by k sub small n is a simple graph that contains exactly one edge between each pair of distinct vertices. A complete graph is a regular graph of degree n minus 1. Yes. How many edges are present in a complete graph? N minus 1. Oh, NC2. Got it. Negative n minus 1 by 2. And then connected graph. An undirected graph. An undirected graph is connected when it has at least one vertex and there is a path between every pair of vertices. A graph that is not connected is a disconnected graph. Weighted graph is defined as a special type of graph in which the edges are assigned some weights, which represent cost, distance, and many other relative measuring units. Representation of graphs. Adjacency matrix, adjacency list. An adjacency matrix is a way of representing a graph as a matrix of booleans, zeros, and ones. Let's assume there are vertices in the graph, so create a 2D matrix, adjacent matrix n, having dimension n. If there is an edge from vertex I to j, mark adjacent matrix I, j as well. If there is no edge from vertex I to j, mark adjacent matrix I, j as 0. Representation of undirected graph to adjacency matrix. The below figure shows an undirected graph. Initially, the entire matrix is initialized to 0. If there is an edge from source to destination, we insert 1 to both cases because we can go either way. Representation of directed graph to adjacency matrix. This will also directed because the entire matrix is initialized to 0. Hey, adjacency list. Representation of directed graph to adjacency list. Create the adjacency list for a given graph. Applications of graphs. Yes, are using many important computer science engineering applications such as Computer networks, operating systems, database design, etc. Computer networks. Graphs are used in computer network types or internet protocols to find the shortest path in routing algorithms. So maps. Operating systems. Graphs can be used to schedule the jobs or processes that are needed by the CPU to use the resources required by the process. So computer networks, operating systems, computer networks, shortest path for algorithms. Operating system, CPU, class distribution. Then compiler design. Graphs are used in compilers to check different grammar rules and to check the performance of semantic analysis and lexical analysis. What do these mean? Semantic analysis focuses on larger chunks of text, but lexical analysis is small. Okay, can you just say big and small words? Huh? So in computer networks, they check the algorithm shortest paths. Operating system, they check severe distribution for tasks. Compilerism, they use to check grammatical errors, semantic and lexical ways, big and small. Google Maps, graphs are used to find the shortest distance between two locations. Database, graphs are used in database to show the different states the transaction goes through. Graphs are used in email diagrams. I'm gonna not do the database thing. Graphs use near diagrams, graphic using database to show difference between the transaction was to word or word of timeless. Database transaction. Database transaction. Google Maps distance. Compiler designs, grammar errors, lexical analysis, semantic analysis. Computer networks. Algorithms for the span and operating system says CPU word distribution. That's it? I finished it? What? なんだこれや。面白い。Done with it. It's done like that. It's fine. I want to play the game already, but let me see how much time. I did not start the timer. Oh, let me start. I think that took like, well, 5 minutes or so. So let's start 20 minutes. ASAP, buddy, ASAP. All right. I successfully finished. God, my mom's walking like a ghost and she's throwing me off. Can't concentrate. Graphs is finished. Now it's up to the time where I will suffer the most. Programs. Hmm. I'm just gonna move this right over here. Alrighty. There is some touchy subjects that I'm about to view. That is why I have removed the screen. Not that you guys can actually see anything. It's just better this way. Oh my god. Come on, dude. Hmm? What is this? This is. Oh, you guys can't see anything. Okay, that's fine. Hmm. Oh, heck yeah, baby. All done. Now, you guys can see it. Should I put it here? Mom won't be visible then. I'm thinking where to put it. Okay. Time to check the stream. I'm just wasting time. Just because I can play games again. Yay! How many people watched it? 14 views. Heck yeah, baby. Heck yeah. Well, I shouldn't expect views from these videos. Well, we got 116 views then, so I should probably expect views from these videos. I mean, this is. I got comments from this video? What the? Let me check comments. What? Yo, bro, you killed it. Oh, well, we got 13 minutes left. So this is unit one. Definition, importance of data structures, abstract data types, and their implementation, overview of time complexity, searching techniques, linear binary, blah, 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 blah. What do I need? I got searching, I got sorting, baby. I got searching, I got sorting. I got like 5, 6, 7, 8. I got 3 hours more, so that means I got 6 more sessions. I can do it. Introduction. I don't want to introduce. Okay, let's go like that. A data structure is a collection of data types, data values, the relationships among them, and the functions or the operations that can be applied to the data. A data structure is a collection of data types, the relationship among them, the function of operations that can be applied to the data itself. So it's three things. It's the collection, it's the relation, it's the number of operations performed on the data. That's called data structure. Data structures are essential components that help organize and store data efficiently in computer memory. What are they useful? Efficiently storing and in computers. They provide a way to manage and manipulate data effectively, enabling faster access, insertion, and deletion operations. What are their other uses? They make accessing the data immensely fast by also implementing insertion and deletion operations faster. Common data structures include arrays, linked lists, stacks, queues, trees, graphs, etc. Okay. Definition, applications, examples. Done. Classification of data structures. Linear data structures. These structures store data in a sequential order, this allowing for easy insertion and deletion operations. Array, linked list, stack, queue. Non-linear data structure. These structures store data in a hierarchical or interconnected manner, this allowing for more complex relationships between data elements. Example include trees, graphs, and hash tables. Applications of data structures, database management systems, operating systems, compiler design, artificial intelligence, graphics, and multimedia. To store and manage large amounts of data is database management. To manage memory processor files is operating systems. To represent source code and intermediate code is compiler design. To represent knowledge and perform reasoning is artificial intelligence. To store and process images, videos, and audio data is graphics and multimedia design. We got database, stores large amount of data. We got compiler design, we got source code and intermediate code. We got artificial design, artificial intelligence. It provides reasoning and information. We got multimedia and graphics, images, audio, videos are stored. Operating systems to manage memory process files. Items. Dog, dog cell, dog ag, cardog, cardog, gadog, gadog. Okay, I'm gonna stop. Abstract data types, commonly abbreviated ADTs, are behavior of classifying data structures based on how they're used and the behaviors they provide. Abstract data type is a type for objects whose behavior is defined by a set of values and a set of operations. Didn't get it? are a way of classifying data structures based on how they are used and behaved. Okay, so how they used and the behavior is how they classify abstract data types. Got it. Abstract data type is a type or class for objects whose behavior is defined by a set of values and set of operations. So it's a class which is defined by its operations and set of values. The definition of ADT only mentions what operations are to be performed, but not how these will be implemented. So it's all about operations and behaviors, but not about implementation. It does not specify how data will be organized in memory and what algorithms will be used for implementing. It's called abstract because it gives an implementation independent view. Well, it's in the name abstract, so it doesn't give an implemented view. So it gives an abstract way for users to see an independent implementation view. So it doesn't specify how to implement, but it just gives an abstract view. It doesn't specify how data will be organized or how it will be implementing operations. So the abstract because it gives an implementation view. The process of providing only essentials and hiding the details is known as abstraction. The process of providing only the essentials and hiding the details is known as abstraction. Just the thing I like. Abstract data types. The user of data type does not need to know how that data type is implemented. For example, we have been using primitive values like info, char only with the knowledge, blah, 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 they're implemented. So user needs only what they can do, but not how it will be implemented. Okay, I'm kind of understanding what these. Okay. There are three ADTs: list ADT, stack ADT, queue ADT. Complexity. Efficiency or analysis of an algorithm is performed by using this following method. Why am I reading this? Why am I reading this? Hmm, further read this. Uh, Time complexity or space complexity of an algorithm is represented in functions like f of n, g of n, etc. Yada yada yada. So if f of n is your algorithm code, then algorithm efficiency blah 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 blah. I'll read just a power, but hmm. Mm, much time though. Feels like a chore. It shouldn't feel like a chore.
Super hexagon. Begin. Line. Triangle. Game over. Begin. Line. Game over. Begin. Line. Triangle. Game over. Begin. Game over. Begin. Line. Triangle. Game over. Begin. Line. Game over. Begin. Line. Game over. Begin. Line. Triangle. Square. Game over. Begin. Line. Game over. Begin. 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 Game over.
రేపు ఏం ఎగ్జామ్
డిఎస్
అవి ఎందుకు అలా వాల్యూమ్ ఫోర్ చేసుకుంటారు దాంతోని
చదివాను 5 minutes ఆడుకుంటాను.
ఆ కళ్ళు చూడు కొత్త లోనకి పోయే చాలులే లేచి స్నానం అది చేసి వెళ్ళి బయటికి వెళ్ళి చికెన్ ఏది వస్తే
రక్తం పో.
ఎడిట్ అయిపోతుంది
Begin. Line. Game over. Begin. Line. Game over. Begin. Game over. Begin. Line. Triangle. Square. Excellent. Game over.